And I'd like to introduce Susan Jaster. She has been assisting farmers and ranchers in West Central Missouri with practical, biological, resilient solutions to agricultural issues and product marketing since 2009 for Lincoln University Cooperative Extension, Innovative Small Farms Outreach Program, and the Missouri AgrAbility Project. She is a sheep rancher who uses adaptive grazing techniques to conserve soil, health, and water quality. Susan, I'm going to turn it over to you.
Thank you very much, Tess. I appreciate it. And I guess you can hear me all right. And so we'll go ahead and get started. We're going to do a little bit of a live demonstration here. And so I'm going to adjust my screen so you can see this. It's called the bread and flour demonstration. And what we've got here is some flour, just common everyday wheat flour, and 2 slices of wheat bread. And we're going to talk about these as if they were our soil. The flour is going to represent our depleted soils, and the bread is going to represent our good, healthy, aggregated soils. So what is flour? If you think about flour, it is just the kernels of wheat, and the bran has been removed, and then it is ground into a fine powder so that we can use it. But it is no longer a living thing. It's now an ingredient. And then what is bread? Bread starts out the same way as flour, starts out with flour, and then we add things like water, sugar, salt, fat, and yeast. So when water is added to yeast, we wake up the dormant live yeast cells, which really helps raise the dough and aggregate the other ingredients into a sponge-like material, as you see here in bread. Now let's look at our degraded soils, and we're going to just talk about flour as if it is our degraded soil. And what I'm going to do is we're going to pour some water on this. We're going to let it rain on our flour. So I have 1/3 cup of water here, and I have a little cup here with holes in it to show that, so we can sprinkle through there. And we're just going to hold this up several inches above our flour and pour the water in and let it start raining. And as you look at it, the water kind of beads up on top of the soil there. And then you also might notice some pooling. So this is very similar to what happens when we have a lot of bare soils and we have rain events. So we can see this water is ponding and then pooling and flooding around to the edge of the soil here, and it's dragging some of that flour with it, which could represent soil. At this point, you notice that the water is pretty murky there. And I still have a slight amount of water left, so I'm going to dump that out because we're going to flood our plate. And so what do we notice about all of this? You can see that it's really puddled, really pretty far out to the edges. So that would represent runoff. And when you have runoff, that takes all the chemicals with it that are sprayed on or knifed in. Anything that's on the surface of your soil is going to run off with that water. And it's going to take everything with it. So we lose like up to 4 tons of topsoil per acre per year to erosion. And that is pretty devastating when you're trying to raise a crop that needs that healthy part of the soil in order to function. So now let's look at water infiltration in this soil here. And we're going to scrape some of this aside. And what do you notice right away? There's still dry soil there. All that water came along on that surface, but our plants underneath are not wet. Our root zone is not wet at all. We have all of this dry flower, dry soil. So that's the other problem with water that with soil that has no roots in the ground. Then we see very dry roots, and that's when drought really hits us hard, because we have not reserved any water in the soil by having roots there. So that water is all on the surface, and it can evaporate very quickly, and that's the only moisture our plants get, is what's at the surface. Now let's try this again on top of our 2 slices of bread here. We're going to pour the same amount of water, 1/3 of a cup, in the sprinkler, and we're going to hold it up off of there and let it rain on it. And you might notice that it's soaking in pretty well. So bread is a living thing because we have the addition of yeast in there, and that's what helps aggregate the bread. So it has those little tiny holes where the oxygen can infiltrate and make those little bubbles, which makes it nice and fluffy to eat. But also, when we have a living soil where there's a lot of bacteria and fungi, earthworms, all those things need oxygen, and the roots being in the soil help convert sunlight to energy or sugar, and that goes down in the roots, and those roots talk to each other in their own little way, and they have mycorrhizae fungi on them that helps them hold water. It's a pretty complex system, but I'm going to dump the rest of this water on there so you can see that I've used the entire 1/3 of a cup for the bread. And I had about that much water left when we did the flour demonstration, and I used all the water for the bread. And you might notice that this bread is nice and squishy, and even underneath it's nice and squishy. And then if we hold it up, we can see that it's wet under there, and look, I hope you can see that it's dripping water. So what we gain by having a living soil is that the water can stay in the soil, prevent us from having a severe drought. It also keeps the water in the root zone, and then gravity pulls it down further so that it can fill our aquifers. And all the time the water is soaking down through that substrate and all those rocks and the different parts of geology that are there, it cleans the water so that by the time it gets to the aquifer, it's very clean. And so I just wanted to give you this as quote unquote food for thought, because a living soil is very much better than a depleted soil. So now I'd like to change gears and come back up to you and do a PowerPoint for you to talk more about this and how we can actually let nature do the heavy lifting for us so that we have better soils, have a living soil that is also functioning in its nutrients, and it functions as well in our water cycle. And I'm going to share my screen now and go back to the original and from the beginning. There we go. All right. So now I was talking about letting nature do the heavy lifting. And can you see my screen?
Yes, we can.
Okay, great. Sorry, Tess, I'm a little nervous here.
That's all right.
So I work in Missouri and in the central region, so I am close to Kansas City. And Lincoln University is in Jefferson City in central Missouri. And I do a lot of work for AgrAbility. Now, I'm going to go into looking at this property. And this is an example of what you should not do. And watch that X. This is the same tree that you're going to see in the next photo as well. And I just put it there as a marker. But what you're looking at here is some very highly overgrazed pasture. All that's left is trees. And yes, the grass is green, but it's about maybe 1/4 of an inch tall. And under that big tree, you see a lot of cattle. Well, they live there most of the time of the summer because that's one of their only shade trees in this pasture in the front. And the guy cut that tree down at some point, thinking that was draining his pond. And so you no longer see that nice big tree in this photo. And I have the blue X there, so you still have an orientation of that other tree. You notice his pond is very dry here. And in the foreground, you can see some huge rivulets of erosion where the water has run through there and cut away all that soil. And you also still see some very short grass. And this is from 2016, I believe, to 2020. And then now the next picture is going to show you the same property. Watch for the X. Now, this is a 3-inch rain event in 2021. And 3 inches is not a whole lot, but when you get 3 inches all at one time, it can be devastating when your soil is super depleted. So as you can see, the water is just rushing in there into that eroded section like a waterfall, and it's cutting away more and more soil as it goes. And after this 3-inch rain event, and then rains from earlier this year, those are now almost 2 feet deep in those rivulets where that erosion has been occurring, because he has cows on it all the time. He never lets the grass rest. And so it is always continuously short. So, you know, if your soil is biologically active, which means that you have a lot of little bacteria and fungi working in there, you have a lot of roots in the soil. And so that means you can also have earthworms and larger insects that are soil, live in the soil. But it's super important to have this biologically active soil, because that helps us to tolerate a 2 to 6 inch rain event. And we know now, according to weather systems, weather reporting meteorologists and things like that, that we're going to see more of these 2 to 6 inch rain events. It's going to be more and more common. So if we have biologically active soil, we have fewer problems with this. There's, you know, flooding and drought. If usually, as we watch here in the Midwest, if we have a lot of flooding, then we seem to go right into drought after that, because our, you know, it just seems to be part of the system now with climate change. I'm also noticing high winds more often, and very high temperatures and super cold temperatures. So we're going to see much more of these extremes as we move into the future. So that's why it's important to have biologically active soils, because they can help us have resilience to all these things. I don't know if you have listened to understandingag.com. They are, that would be like Gabe Brown, Shane New, and Dr. Alan Williams. And they have done some studies with regenerative systems, and they've tested all over the world. There's these regenerative systems, and they are finding and getting good results using these practices, no matter what the soil and no matter where the soil is. They are seeing very good results in using regenerative practices. Well, they did in 2020, they collected a bunch of soil samples from 45 farms in the northern plains and the prairie provinces. And they took samples at 12 inches and also at, I think, well, they did them all at 12 inches. So that's kind of getting down below our root zone for most shallow rooted plants. So that's pretty normal for like vegetables and basically our field crops. And so they did both a Haney soil test and a total nutrient extract test. And they did that on all the samples. And if you reading the screen there, it looks pretty unbelievable, but the average pounds of nitrogen across all those farms, the average was 4,000 pounds of nitrogen. And then they looked at phosphorus, that was at 1,200 pounds. Potassium came in at 11,000 pounds. That's a lot. And the least amount of nitrogen on any of the farms, now remember the 4,000 was an average, the least amount they found was 1,000 pounds per acre. So what does that tell us? That tells us that all these things that we have been adding to our fields over the years basically filters down and is sitting right there at that 12-inch depth. But because our soil nutrients are not functioning and our water cycle is not functioning properly, then those are out of reach. So what can we do to get a hold of all those nutrients that our plants need in order to make them healthy? We are going to have some long roots in our soils, and we need to have lots of roots, and we need to have them covering our soil all the time. And I know that is a challenge for our cash crop folks, but there's ways to do it. And there are lots of more methods and machinery to help us with those transitions. Here's another reason why we need to worry about what is happening in climate change. The 100th meridian is basically the division where the humid east meets the arid west. Okay, and the 100th meridian has been pretty much the standard place that we've always thought of where the east and west meets. Well, when you look at the maps now, we are currently seeing that line. It has traveled 140 miles just since 1980. And there's a lot of us probably listening who remember 1980. It's not that long ago, but the 98th meridian is basically between Wichita and Topeka. You know, it used to be way out there at the break in Oklahoma of the Panhandle. That was the 100th meridian. Now the 98th is where it is now, and that is between Wichita and Topeka, Kansas, and Missouri. Kansas City, Missouri is on the 96th meridian. So basically here in the Midwest, the desert is moving toward us. And we're going to see, that's why we're going to see so many more of these extremes in weather. Tilling is our #1 enemy for soil. Excuse me. I need a drink. Tilling is the #1 enemy of soil, and this lets all the carbon out of the soil. That's what we're trying to sequester. We're trying to keep the carbon in the soil, and carbon is a movable thing. In other words, it changes and fluctuates as time goes on and from season to season. So it's not always going to be the same. So we want to keep as much of it in the soil as we can. And every time we turn up our soils with, well, and I'm hoping most of you are not using a moldboard plow, and you're using no-till instead, which is minimal tillage. And there's even better improvements on the no-till equipment nowadays. They just scratch the surface and just make a nice light seed bed. But the problem with churning up all this soil, we're interrupting the lives of the mycorrhizae fungi. And those communities take around 6 weeks to recolonize. So basically you just scattered all of them everywhere every time you till like this. And that goes for gardeners as well. Plus, when we make these particles, soil particles, smaller, that removes the oxygen, places for oxygen to travel in the soil. And the sticky part of the covering on roots, it comes from the plant producing the sugar, and the glomalin is that sugar. And that is what feeds the mycorrhizal fungi. And so basically, when you churn up all those roots, you're killing off your glomalin supply, which is what feeds the mycorrhizae, keeps and helps keep all the bacteria and other fungi in balance. So, and you don't have any oxygen here. So that's the tough part about heavy tillage. Now, if we look at a global map, excuse me, and carbon dioxide emissions from soils, and the top map is January. Sorry. And the bottom map is May. And in January, other parts of the world are using tillage. But then in the bottom map, you see how pink the United States and Canada begins to come in May. That is how much carbon is released by tillage. So we have to be careful what we're doing. So a good way to start thinking about these practices is to know your context. Your context is where you are and what practices you already use. And like, do you have livestock? Do you just have cash crops? Are you a market gardener? And excuse me, how can you learn about regenerative practices that will help you in your work? The next thing is, we don't want to disturb the soil. And that means by mechanical or chemical disturbances. So if we are using a lot of chemicals, that disturbs the soil. And if we are using heavy equipment out there to till, that's another kind of disturbance. And then we're going to talk about another kind of disturbance later, but that will help this. We want to keep our soils covered and build surface armor so that protects that upper layer of the soil, which also helps moderate the temperature of the soil, which is also another important factor in keeping our microbes happy, because they like 55 to 65 degrees. And most of the time, if the grass is short, like on those first pictures I showed you in this presentation, the temperature of the soil is 30 to 35 degrees hotter than normal, so than ambient temperatures. So if it's 100 degrees outside in the air temperature, then the soil can be up to 130 to 140 degrees because it keeps adding, the temperature adds up after a while. So if we don't have tall enough plant cover on the soil, it's going to basically cause a lot of high temperatures, which kills the good bacteria and fungi in the soil, as well as the bad, but it kills the good ones too. And it is also very hard on the roots of the plant because, for a lot of reasons, the plant cannot collect sunlight, for one thing, because it has no leaves above. And when it can't collect sunlight, it doesn't continue to grow. And we know now that it takes up to 17 days before the plant can recover from being very short, because the roots slough off. They kind of die back. So if you have a couple of inches of plant above the soil, you're only going to have a couple of inches of roots as well. So the other principles of regenerative practices are to have diverse plants, animals, and microbes, as well as insects. And then you want to have a living root in the soil at all times, or as long as possible. And we also want to have, look at our animals, if we have livestock on there, because they actually can help us do a better job of having active soils. Then we want to look at the adaptive stewardship. This shows that nature is compounding and cascading. It kind of, once you get things started, it gets better, and it will basically, it has a cascading effect in that nature is never neutral. It's only positive or negative. And so when the more positive things we can help on our farms to be more positive, the better off our soils are going to be, the healthier everything's going to be. And things that just kind of become resilient, and they become redundant, which means you have extra. And that's what we want to see. We don't want to be super efficient. We want to be redundant. We want to have extra, so that we can, if a flood comes along, we can recover from it faster. Also, we want to talk about disruptions. Now, before, in that other slide, we talked about, well, when we talked about tillage, that was a disturbance. But disturbance is bad, but disruption is good. And that helps us prevent patterning. You know how a lot of people like to turn their cows out by the calendar, like maybe April the 1st, we turn cows out into the pasture. And that's farming by the calendar. That is a pattern. That is something you do every year. Well, we've got to stop doing that. We've got to go out and observe what is happening so that we can prevent patterning. And so if we always turn cows out in the east pasture first, then the next year we should try going to the west pasture first and changing it up, and maybe changing how long they stay in that pasture before we move them. We want to take half and leave half of whatever is there. Also, we want to have diversity in what's out in our pastures, including our livestock and our tiny little livestock, our subterranean livestock in the soil. So if we don't grow a monoculture, if we have a variety of plants out there, if we have a variety of livestock out there, or the numbers of livestock, anything to change it up a little bit, that helps with diversity, and that helps promote more resilience, and more redundancy. We get more. So regenerative ag practices, they create a better future for our farms. Resilience is basically risk management for climate change. And that's what I'm talking about. The more we allow nature to be itself and not add a lot of things that are chemicals or tillage, then nature can kind of take care of itself. And this lowers the need for those costs and inputs. And fewer inputs requires less physical labor of us. And that's where I come in with AgrAbility, is that, you know, as we maybe have a different ability than some people, than the common, not the common, but the population, the regular population, if we are differently abled, then perhaps less work will cause us less fatigue and stress. And I don't care how abled you are, then less fatigue and stress is always better. We need our mental capacity to keep us going. And if we're all stressed out, we're not doing very well. So I have found that regenerative agriculture helps us in our personal life as well.
Susan, there's a comment from Erica. It says, perhaps in some sense there is on a level natural monocultures such as walnut groves, but in this case, another way of thinking of natural diversity is vertical diversity. Maybe the woods are all walnuts, but beneath the walnuts, there would be different shrubs contributing to the soil diversity biological activity.
Exactly. That's, it's pretty hard to have a very sterile place to grow something. I mean, if you have ever tried to grow under cover, like with Weedex or putting down plastic and, you know, trying to grow your plants in plastic culture like they do in high tunnels and some field vegetable crops, you know, the weeds still want to pop up. And they're trying to tell us that we shouldn't be such a monoculture. So there's lots of ways to do that. And vertical is a very good way to go, because then we still have vining plants, we still have shrubs. I mean, I would not consider trees to be a monoculture unless they were in a plastic culture and, you know, planted into that sort of a crop in that sort of a field. So yes, vertical is a very good way to go. That's basically permaculture, and permaculture likes more things together. In fact, they really get into it a lot because they add different kinds of trees. They add nut trees, fruit trees, and then you have shrubs that maybe have berries and different kinds of things like that. So you're going to change how your soil acts toward that, but it's going to be better because now you have a huge diversity in the soil with all those kinds of plants. And if you're not into permaculture and doing a lot of the social side of how permaculture functions, then you need to know about agroforestry, which is the management of permaculture. And if you're a row crop person and you're going to put in a grove of trees, then agroforestry will help you wrap your mind around permaculture, which is still a good way to go, because that is healthier nutrient cycling and water cycling. So this slide shows us that we should go out and look at our soil, dig an 8 by 8 by 8 hole in your soil and count how many earthworms you dig up. What does the soil look like? And it should look like a chocolate cake texture. And some people tell me, well, I never look at it, I just eat it. Well, next time you slice open a piece of chocolate cake, look at it and see that texture. There's holes in there. There's different size pieces of cakes. Well, that's what our soil should look like. We should find different aggregates, which is just the particle size, different sizes there. And the next thing to do would be to get a Haney test, and not just an NP and K soil test, but a Haney test. That will tell you what your active carbon is, what your potentially mineralizable nitrogen is, and a lot more. I have been, my soil at my ranch is, I'm bringing it back from row crops, which was really hard on it. But after, we're in our 5th year now, but by the time we had 3 years in on regenerative practices, we were already seeing a score of over 850 on active carbon. So it can be done, and it's worth it. So you can also sequester carbon by growing cover crops. It's a great way to help keep the soil temperature down and get a diverse mixture on your soil. The purple arrow is showing sun hemp, so you can see how pretty that cover crops can be. The pink arrow is showing us some millet, I believe, and the blue arrow is showing hay beans. If you don't know what hay beans are, that is just a leafier version, a forage version of soybeans. And so we have grass here, which is our millet. We have a forb, which is our sun hemp, and the hay beans, which would be a legume. So we have lots and lots of plants here, but you want a kind of a 1-to-1-to-1 mixture of grass, forbs, and legumes. That helps balance it out, because that helps you have different lengths of roots in the soil, which can help you collect nutrients from different portions of the soil. So what can cover crops do? They can help you change those patterns. Remember, we talked about disruption instead of disturbance. And it brightens those communications between plants, because now the plant is not doing the same old thing. Like if you just have a fescue field out there, they get the nutrients, and the little mycorrhizae kind of get bored, and they don't have, sometimes you'll see problems with your fescue because there's not enough predators anymore, predator insects and microbes to take care of all those endophytes. So I like to put in a cover crop. So basically perennials in a perennial pasture to help wake that up. And you get more nutrient uptake if you use cover crops. You're going to have different lengths of roots like we talked about. And it does help mine up a lot of the nutrients from different depths. And it makes a great winter stockpile. If you can use some winter hardy crops in with your grasses, you would be amazed at how much longer your livestock can stay on those paddocks, just because you have more thicker kinds of pasture for them. And our context here in adding cover crops is that we want to know the purpose of our cover crops. So there's lots more kinds of cover crops than we ever used to have. We're going to set some goals, and we're going to plant crops for the right season. So for me, I usually am planting cover crops in about the end of March, maybe April, when the weather is nice and moist and we know we're coming into warm weather. So I'm going to plant cover crops that are going to be for summer grazing for my sheep. And then about in August here in Missouri, between mid-August and the end of August, I want to try and get my cover crop in for my winter grazing. So I'm going to put winter hardy things like turnips and radishes, like the different kinds of big tiller radishes, and maybe some winter oats or winter wheat. I prefer winter oats because the sheep like them better. But we have a lot of great grazing in the winter just because we have used cover crops on our perennial pastures. Now, this is what you want it to look like. And I know a lot of people have a heart attack when they see pastures that tall, but that's really what we want to see. We want to see these these are South Pole cattle at Greg Judy's farm here in central Missouri. And they were so happy. Those cows they walked in there when they let the wire down and let them into this part of the paddock. They didn't call to each other. They weren't worried about anything. They just put their heads down and kept eating. That's what we want to see. Take that, as you graze, you're probably going to start with take half, leave half, but he actually grazes only the top 1/3 of the plants and then they move again. So he has quite a bit of ground. Yes, I know. And he can do that, but he has quite a bit of livestock to move over that ground. And so when you only take the top 1/3, your plants grow back faster. Recently, I've been working on a grant and I'm trying to finish that up now so we can have some data on that. But we checked to see what kind of diversity we had. We also checked to see what the diversity was in our insect population. And we did 4 trials. We did a spring and a fall for 2 years in a row. We planted cover crops before each time we grazed it, and we measured it all before we let the animals in to graze. So we took an inventory of plants, and it's interesting to see from year to year. If you know what that plant is in the middle, it looks like clover, but it's really black medic. And we had a lot of it in all the pastures of 5 different ranches in 2 different counties. And the next year, because we grazed it properly and woke up that soil, we had a lot less black medic, which means it had done its job and it was not needed because the soil nutrients were functioning. So when we graze, we want to be careful not to graze it down too short. The roots slough off, there's no photosynthesis, and parasites are actually sitting right there on the stem. If you have sheep and goats, you don't want to let them in on short pastures because the parasites can climb up to 4 inches up on that blade of grass. If you graze it short, then those roots slough off. There's no place for the mycorrhizae to live. There's also no shade above the ground. And so you get high soil temperatures. And then all the plant communication stops because the mycorrhizae can't go back and forth on those roots to help each other, help plants together, farm together. Plants, the mycorrhizae basically is a little farmer, and they bring all the food and water to the roots. And so that kind of fungi just builds all kinds of networks. They have like a telephone system. It's very cool to see it when somebody takes the time to open it up and let you look at it. But mycorrhizae are super important. But if it's so hot they can't live there, then it takes a long time for your plants to recover. So we don't want to graze it this short. Nature needs resilience, nature needs redundancy, extra, in order to recover. Sorry. When we graze those plants up high or cut them up high when we're making hay, that helps it remain in a vegetative state. And the plant only sloughs off a few inches of the root, if any, and maybe some root hairs. But the plant can go on feeding itself because it can still produce glomalin. So you need to rest your paddocks and 30 to 60 days until the tips grow back onto the grass. And a 24-inch plant quite often has anywhere from 2 to 10 feet of roots. So we were talking about collecting those nutrients at different levels in the soil. That's why 10-foot roots are important. Also, anything that crawls on, sprays on, grows on your farm should remain there until harvest or sold. This is how we prevent, that means we need to prevent runoff. That will help us prevent the spread of disease. It'll prevent chemical trespass. And I know that a lot of you have heard about the dicamba problems that have been here in Missouri, especially in the Boot Heel. There's almost no vegetables grown down in the Boot Heel anymore because they have all been oversprayed by dicamba from the big corn and bean and cotton fields. And so there's a lot of high tunnels down there that they got through NRCS, but there's nothing growing in them because they've all had chemical trespass from their neighbors, and their vegetables were all ruined. So while we're waiting for our soils to become biologically active, and it only takes like 18 to 24 months, while we're using these new practices, it does take a little bit of time, but it's not like nearly as bad as we thought, because we used to think that it would take 100 years to get 1 inch of topsoil. Well, it doesn't take that long if we are doing these regenerative practices. So for our livestock, we want them to have a superior mineral, preferably like a Jerry Brunetti mix, in order to help them get through that transition while we're helping our soils to become biologically active. And Tess, did we have any other questions? I could go into this part.
Yeah, somebody commented just a little while ago, daikon or oil seed radishes with a question mark in them. Beautiful.
Yes, and that was what I was trying to refer to, and I lost my word, so thank you for that. Daikon radishes are great. And here in Missouri, if we can plant turnips and daikons around the end of August, we'll have a crop of turnips or radishes by Thanksgiving. And I mean, they're ready for Thanksgiving dinner. So it's pretty wonderful how fast things grow when the soil is functioning really well. And then once the sheep love turnips and radishes, they will go out there and eat the tops right off of those, and cows love them too. I've seen cows stand at the fence and bawl because they couldn't get into the turnip field. And my sheep love them. They'll chew off the shoulders of that turnip because it tastes so good. When after it's frozen, it gets sweeter. So they love it. Okay, let's see. This part of the talk is about building a medicinal hedgerow or a wall, and it does not need to look this formal. Basically, you are adding herbs and other medicinal plants, and maybe things like garlic for your animals to eat. And basically, you put them inside of a little fence that the plants can grow through the fence. And basically the animals eat off the leaves. They need tannins anyway, so why not let them have the leaves of these plants? And so basically this is just another way to give more nutrients and more diversity to your pastures by planting different kinds of plants. And that could be any tree, because you could coppice a tree, which means just to keep it short and let it bush out. So you're basically using trees, especially like honey locust, or because honey locust is a legume. And there's a lot of trees that all these nutrients animals need could be coppiced and kept short and let them have branches down lower, so that your animals can eat the leaves off of. And if you don't want them to eat the tree back too far, then you set up this little pen so that the plant and the tree can grow through it. And then the animals get only that much. And then that way it resprouts and regrows as time goes on. So it can basically be used, your animals will self-medicate by using these plants and eating them for different nutrients that they need. I mean, steak and potatoes is great, but if you get that every day, 3 meals a day, it's not special anymore. And you're also getting only the same nutrients over and over. Well, animals need diversity just like we do in food. So this is a great way to help them self-medicate if they need it. And they will go and select what they need this way. So it's not something you have to do because you can do it with cover crops as well. But if you want more medicinal plants in there, they will use them. And this is just a way to do that. If you'd like more information on that, please contact me and I'll help you figure it out for your area. And I went backwards again.
Susan, there are a couple of questions and we have like 9 minutes left.
Okay.
So the first one says, I work on a farm with a lot of perennials in raised beds. How do you recommend we take care of that soil without rotating our beds with perennials?
Okay, so what you can do without rotating is change up what crops are next to your perennials. If they're already big enough to where they're shading things out, shading other things out, you can either trim them and coppice them, like if they're a tree, or you can dig out what's already planted there, part of it, and start something else. That helps you build diversity. You can also use cover crops underneath these. If you use seed tolerant type seeds, plants, to go into those spaces if they're pretty shady already. Did that answer it, I think? And I mean, I can talk more about that. Diversity is always better, but I know when you get perennials, you have to think of other ways. Another thing you can do is to trim the trees differently, or not as much or more. So certain times of the year, maybe when you are doing coppicing work, which is usually in the winter when the sap's not flowing, maybe this year we leave half the tree not coppiced and let it grow out. Maybe we graft onto them so that something changes in the plant world for that plant so that the other plants around it can survive and create diversity.
They said, yes, thank you.
Okay.
The next one said, so my agriculture is really just me interested in growing things in my lawn. Would a totally boring lawn that had been whatever grass for however long be mostly biologically dead? The tomatoes I put in and the peppers and even sunflowers were just barely something. I don't know if previous owners used chemicals on the lawn or not.
I think I would assume, and I know it's dangerous to assume, but I would assume that they had used chemicals if it is that perfect. You know, you can leave the lawn intact and just cut out little places and take the turf away on those certain places. And I would do it strategically, you know, so it's easier to water it and things like that, and plant pollinator crops, you know, flowers, maybe do some other vegetables in there. But as you cut the turf out, you can always add a lot of compost there and then plant into that. Another thing you can do is in the winter, do the lasagna method and layer some cardboard out there where you've cut the turf away, put some cardboard down, and then put some old hay, started, you know, rotting hay or straw, and then put another load of compost on that, and then plant into it next spring. So yeah, you've got to get the mycorrhizae fed. You have to feed them. So if you're going to disturb it, you got to feed them. And that's a way to do that. If you cut the turf off in that little, you know, in your area, in that spot where you're going to plant something else, you still have a lawn intact, and you may, you know, hopefully you won't get in trouble with your code people if you're in town. But you can feed that soil in these little patches, which will disrupt what they're already doing and help them create more mycorrhizae.
Okay. Another question. Can you expand on the disruption aspect?
Okay, yeah, disruption is like I just talked about in with changing your lawn into more productive soil, is basically just that. You can do little things and you can do big things. Disruption is adding the cover crop in on top of a perennial pasture, and that would be a disruption. You can strip till it, so leaving some of the sod intact or some of the soil the way it's growing now, and then cut out strips and plant your cash crop in there. So you're just doing a little at a time and not changing all of it at once. So that would be a disruption, because you're going to feed it as well, because you've either tilled it and then added compost or other nutrients, fish oil and things like that. And then that would get you a more diverse pasture or cash crop.
All right. Yeah, I appreciate.
Any other?
That person said, thanks. There was another, thank you. I have plans to add compost this fall, and the lasagna idea sounds intriguing. And somebody else said, I use a lot of clovers, chicory, etc. below my perennials.
That's very good. That's a really good idea. Because those plants can, they have really good deep roots, and they will basically bring all those nutrients up to your other crops. They'll farm them up for you or mine them up.
And somebody said, incredibly valuable information presented in a manner that I can understand and begin to apply immediately. Thank you, Susan. Very
welcome. That's what I try to do, because I need to get it in my head. So that's how I have to talk about it. And you can always contact me. There's my phone number, and my email is jasters@lincolnu.edu. So you're very welcome to contact me if you have more questions, and I can give you plenty of resources about this. And like I said, this helps us in AgrAbility, because we're not farming so physically hard. We're not paying for all these inputs and everything. So it can help us with our disabled farmers and ranchers, because they're going to spend less money. They're going to have a better quality of life. I have found that I have a better quality of life since I have gone with these practices, and my animals look good all the time. So, and I found after bringing this back, my soil back, and I don't have very much land, but I run 150 head of sheep, and I manage probably 50 acres plus my 10. And I found my first dung beetle this year, and he was coming up for a drink when it was so very hot, and I found him in the water tank for the sheep. So I'm pretty happy that we have dung beetles back doing their job.
Oh, great. Somebody is asking if the slides are available. So this recording will definitely be archived on the agrability.org website. And Susan, if you don't mind sending a copy of the slides, we can also put those on the website.
Okay, sure.
All right. And I did put the link for our evaluation in the chat. I will share that one more time in case people can't find it. So if everybody could just take a minute before they leave and fill out the evaluation, we would appreciate that. And Susan, any last messages quick for the last minute?
I see somebody has recommended the One Straw Revolution. That's a very good book. And there's lots of new books out now on regenerative vegetable production. You might want to look for those. And if you need suggestions about that, I'd be happy to send some your way. Just contact me and I'll get them for you. But thanks for the opportunity today, and I hope the information was helpful and I enjoyed it. Thank you very much, Tess.
Thank you, Susan, for sharing your information with us. We appreciate it also. All right, I am going to stop the recording.